Hello, good day. How are you today? Okay, so are we ready to get on with today's lesson? Good. In today's lesson in mathematics, we are going to be learning about ratio. We are going to be learning about ratio. What ratio means, the sign or symbol that represents ratio, simple solvings of ratio, and so on. So are we ready to get into today's video? We are with our books and our pens or pencils to get into today's videos, right? Good. Okay, let's go. What do we mean by ratio? Ratio is a way to compare two quantities or amounts. Is a way to compare two quantities or amounts. Ratio can be expressed in different forms using a colon symbol, which is this. This we know it as a colon, right? But in mathematics, it is known as the ratio symbol. It is known as the ratio symbol. It is not called the colon. It is called the ratio. And it can also be written as a fraction. So in today's video, we are going to know how to write equations in a ratio form and also can be represented in a fraction form. Okay, so are we ready? Now we have here an example. If you have 2 red marbles and 3 blue marbles, the ratio of the red and the blue marble will be 2:3. It is not 2:3. No, it is 2:3, which is they are comparing the 2 red marbles and the 3 blue marbles. That's why it's 2:3. And it can also be written as a fraction 2/3, where the ratio symbol changed to a fraction. Okay? Do we understand that? Ratio is just all about comparing quantities or amounts, fruits, numbers. It's all about comparing. Okay? It's when you compare two things, when you compare different things together. That is ratio. So ratio is a way of comparing two quantities or amounts. It can be expressed using a colon or a symbol. Sorry, a fraction. Okay? Do we understand that? Just like our example, we have 2 red marbles and 3 blue marbles. We are to represent them in a ratio form. So we have 2:3, not 2:3. And it can be written as a fraction 2/3. So we're going to be looking at some examples to help us understand better and make our knowledge broader. We have here number 1, you have 4 apples and 6 oranges. You are comparing 4 apples and 6 oranges. So it will be 4:6. Remember, it is not 4:6. It is 4:6. And this is not the simplest form. We can reduce it to its simplest form. And how do we do that? By dividing both sides by a number that when they divide the given value over there, it won't have a remainder. We have 4 and 6. What number can divide 4 and 6 without a remainder? We have 2. 2 can divide 4, it will give us 2, and 2 can divide 6, it will give us 3. So we have 4:6 as also 2:3. This is the simplest this can go. You cannot reduce it again because no number can divide 2 and 3 and won't have a remainder. Okay? Do we understand that? Good. Here, the second one, in a pet store, they have 5 cats and 10 dogs. We are to represent this in a ratio form. So we have 5 cats and 10 dogs. So it will be 5:10. They are comparing 5 cats and 10 dogs. So it's 5:10. This is not the simplest form. It can go a little smaller than this, right? So what number can divide 5 without a remainder, and what number can divide 10 without a remainder? If we want to use 2, 2 can divide 5 and won't have a remainder. 3 can divide 5 and it won't have a remainder. 4 can't divide 5 and it won't have a remainder. But 5 can divide itself and it will not have a remainder. So we say 5 divided by 5 is 1 and 5 divided by 10 is 2. So we have 1:2. The simplest form of 5:10 is 1:2. Do we understand that? Okay, very good. Let's look at another example. Here we have there are 12 boys and 8 girls in the classroom. We are to represent this in a ratio form. They are comparing 12 boys and 8 girls. So we have 12:8. This is not the simplest form, right? It is not. So we can reduce this by dividing both sides with a number that when it divides both sides, there won't be a remainder. So let's say 4 divides 12, would there be a remainder? No. And 4 divides 8, would there be a remainder? No. So we use 4. 4 divided by 12 is 3, and 4 divided by 8 is 2. So we have 3:2. So the simplest form of 12:8 is equals to 3:2. Did we get that? Good. We have here, if you have 4 red bags and 6 blue bags, you have to compare 4 red bags and 6 blue bags. We have 4:6. 4 red bags and 6 blue bags. So we have 4:6, not 4:6. Remember, the colon sign is called the ratio sign in mathematics. So we have 4:6. And this is not the simplest form. Can we divide it to make it, to change it into its simplest form? Yes, we can. We have to look for a number that can divide 4 and also divide 6. 2 can divide 4 and 2 can divide 6 without a remainder. So we use 2. 2 divided by 4 is 2 and 2 divided by 6 is 3. So we have 2:3. The simplest form of 4:6 is equals to 2:3. Did we get that? I hope you understood it, right? Good. Let's go over to another example. Here we are to represent the ratio in a fraction. Remember, we said we can represent ratio in fraction, right? So we have here 8:12. To represent this in a fraction, we have to write it, change the colon sign, which is the ratio sign, into a over sign, which is 8/12. We understand that this colon sign changed into the fraction sign, which is 8/12, no longer 8:12. So this is not the simplest form. We have to reduce it to the simplest form. And what can we reduce to it? Use to reduce it and to give us the simplest form? We can use 4. 4 in 8 will give us 2, and 4 in 12 will give us 3. So we have 2/3 as the simplest form of 8/12. We can write this 2/3 in a ratio form, which is 2:3, not 2:3. It is 2:3. Okay? Do we understand that? Very good. Now let's look at the next one. We have here 5:25. It's not 5:25, it is 5:25. So we have to change it to a fraction. We have 5:25. It will be 5/25. Okay? This is the numerator and this is the denominator. So, well, how can we change this to its simplest form? 5 can divide 5 and 5 can divide 25. So we're going to be using 5 to divide. 5 in 5 is 1 and 5 in 25 is 5. So we have 1/5, which can be written as 1:5. Not 1:5, 1:5. 1/5 can be written as 1:5. Okay, this is the simplest form of this. Did we get that? And this is the ratio form. I hope we understood this. Okay, we're going to be looking at another example. Equivalent ratio. Equivalent ratio is how two ratios look different but they are the same. They look different but they are the same. We have 2 ratio 3 is the same thing as 4 ratio 6. And how did we do that? We did that by multiplying both sides with the same number. You have 2 ratio 3 here, you multiply both sides with the same number. Let's write it as a fraction first. We have 2 over 3 is equals to, we have 2 over 3 here, which is this 2 ratio 3. We are going to be multiplying both sides, which is the numerator and the denominator, by the same number. Let's say we are using 2 to multiply both sides, the numerator and the denominator. So 2 times 2 over 3 times 2. We are using 2 to multiply both the numerator and the denominator. So we have 4 over 6. So 2 over 3 is the same thing as 4 over 6. Like we can see in this diagram over here, we have a rectangle here. So in this image, we are seeing that the first one is 2 over 3. 2 parts are shaded and is divided into 3, right? And here, 4 parts are shaded and is divided into 6. But they are still looking the same, right? Yes. So equivalent ratio is 2 ratios looking different but they are the same. They still look the same, right? Yes. So we have here 1 ratio 2 is the same as 2 ratio 4. And how did we do that? We multiply both sides by the same number. To get an equivalent an equivalent ratio, you multiply both sides by the same number that you are using. Okay? If you are multiplying the numerator with 2, you multiply the denominator with 2. If you are multiplying the numerator with 3, you multiply the denominator with 3. That is what we mean by multiplying both sides, okay? For you to get a balanced ratio. So we have here 1 ratio 2 is the same as 2 ratio 4. How? We multiply both sides by 2. We have here 1 times 2 over 2 times 2. We use 2 to multiply both the numerator and the denominator. So we have 2 over 4. So here we have a circle that is divided into 2 and one part is shaded. So it's just like 1 ratio 2 or 1 over 2. Remember, the numerator represents the shaded part and the denominator represents the full circle that is divided. Okay? So we have 1 ratio 2 or 1 over 2. And here we have 4 parts that are divided, the circle is divided into 4 and 2 parts are shaded. The diagrams still look alike, right? Yes. So there are 2 ratios that look alike. Sorry, they look different but have the same meaning. The circle here is divided into 2 and one part is shaded and the other half part is unshaded. The circle here is divided into 4 and 2 parts are shaded, the other part is not shaded, so they still look alike. They are different numbers but the same meaning. Half part is remaining here, half part is remaining here. Just like here, one part is remaining here, one part is also remaining here. That is what we mean, right? Good. Let's look at another example. Here we have 7 ratio 10 is the same thing as 14 ratio 20 or 21 ratio 30. It depends on the number you use to multiply. We have 7 over 10. You can use 2, you can use any number to multiply. We use 2 in multiplying here. 7 times 2 over 10 times 2. It gave us 14 over 20. So 7 over 10 is the same thing as 14 over 20. Same here, we use 3 to multiply. So 7 over 10 is the same thing as 21 over 30 when you use 3 to multiply. So you can use any number to multiply as long as you are using it to multiply the numerator and the denominator together. Okay? Do we understand that? Whatever number you are using to multiply the numerator, you use it to multiply the denominator also. That is how ratios are equal. Remember, equivalent ratio means equal. They are different numbers but mean the same thing. So we have our assignment over here. I'm sure we'll be able to do it.